patience. Let me request Dr. Miriam to proceed on to her next presentation. Today's third presentation and her second presentation that will be the alternatives to AGP in poultry feed. Dr. Miriam, please proceed with your second presentation.
The second presentation is on AGP alternatives, right?
Yes, yes.
Yeah, yes. Okay. Let me move back to my screen. Can you see the full screen now?
Yes.
Okay, good. Okay, so now that we have dealt with the gut functionality and its effect on, the nutritional aspect of improving gut health and how it can benefit our birds. Now we move on to the second topic, which is alternative solutions to AGPs. So as a note, I am not a veterinarian. I am an animal nutritionist, so I will be dealing more with nutritional issues and the point of view of a nutritionist. Okay, so I'll just briefly discuss these trending concepts, the products that we have, the use of history of using these AGPs, and maintenance of a healthy gut microbiome, and then what are these alternatives to AGPs. I will not discuss everything, but those most important ones, because I think it will consume a lot of time if we discuss all these alternatives to AGPs. Okay. So when we define a trending topic, this is the term that is mentioned at a greater rate and rate than others, and it gets popular through the users or an event prompting people to talk about it. And when we say feed additives, these are the ingredients usually incorporated at small amounts to improve feeding value of feed ingredients or directly influence performance of the animals. So right now, we have a lot of nutritional concepts, and the most trending ones, or the most talk about ones right now, you have heard of this precise feeding. We talk about gut health all the time. Sustainability is, everyone is talking about this. Oxidative stress, feed biosecurity, production of without antibiotics or no antibiotic ever, and then immunomodulations. And this is like a long time already trending topic, which is AGP alternatives. So this is quite a vast topic to discuss, but in the interest of time, we will just discuss the most relevant ones. So what are the product solutions, the trending product solutions available in the market? So what I did is I classified all these additives into categories that will that would best describe them. So these additives can be like classified as probiotic, prebiotic, postbiotics, betaine, enzymes, functional fibers, trace minerals, functional amino acids, beta-glucans or the yeast beta-glucans, phytogenics, natural antioxidants, the organic acids, the short chain and medium chain fatty acids, the oligosaccharides, fructooligosaccharides, xylo-oligosaccharides, and mannan-oligosaccharides. So as a brief history, the use of antibiotics is to enhance the production rate, or the growth rate and production performance of the animals. So when in the past, it is used to reduce pathogenic microorganisms, and that would be related to growth performance. I'm sorry. There are just like people entering the group, and it just keep on appearing, and I get distracted with that. Sorry about that. Um, okay, so what do antibiotics do? They reduce the normal intestinal flora because they compete with the host for nutrients, and at the same time, they reduce the harmful gut bacteria, and that would lead to reduce the performance of the animal. So these antibiotics before are used as growth promotants in the following these two mode of action. So they reduce the growth of the intestinal flora to prevent competition for nutrients, and they reduce the growth of these harmful or the pathogenic microorganisms that will pose a great risk on the health of the animals. So the effect on growth rate may be due to combination of these two mode of actions or one or the other. Antibiotics inhibit the susceptible bacteria and affect the composition of the bacterial gut flora. So in a way, these antibiotics are related to the balance in gut microbiome, that when they are incorporated in the diets, they would be able to affect the population of the bacterial gut flora. So they started to use AGPs, or antimicrobial growth promotants, in Europe in 1974. And after a few years, in 1986, the first antibiotic resistance was detected in France. So in, let's say, in a short period of time, like 12 years, they enjoyed using antibiotics as growth promotants until they have detected this resistance in 1986. So why they restricted AGPs, or the use of these antimicrobial growth promotants? So it was Denmark who first banned the use of of AGPs in 1995, followed by Germany 1996, and then in 1997 all EU countries banned AGPs in the diets. So first they banned vancomycin and avoparcin, followed by virginiamycin, and then lastly avilamycin. They have seen that the use of these antimicrobial drugs is very much related to the development of resistance of these antimicrobial drugs in animals and in humans. So they have already seen this resistance both in the level of animal production and in human health. And then they have concluded that these antimicrobial agents should not be used for growth promotion if they are being used for treatment of human diseases, or they would cause this cross resistance to antimicrobial drugs that is being used in human medicine. And in EU, they started restrictions in 1998 for this growth promoter. So I remember these are the most popular growth promoters, tylosin, these growth promoters to antimicrobial drugs that are being used for humans. And in January 2006, they have this total ban on AGPs in feed all over European Union. So if you look at the usage of this AGP and look at which particular species would be consuming AGP, So this graph shows the annual average AGP consumption per kilogram of animal. So let's say per kilogram pig, they have around 172, they consume around 172 milligram per kilogram of pig, followed by chickens and lastly by cattle. So pigs are consuming more AGPs than chickens, although at 148 milligram per kilogram, chickens, it's already high. So the use of this antibiotic as growth promotant in animals, they see a lot of threat, or there's a big threat in our animal production, as they create antibiotic resistance, which is a great public health concern, as antibiotic resistant bacteria is associated in animals. The one that you find in animals may be pathogenic to humans, and they can be easily transmitted. A lot is being seen on the side of the public or on the side of the medicine or human health, and also in relation to animal consumption of AGPs. So here we can see that among the regions, it's the Americas and Asia which has the highest proportion of growth promoters authorized to use as growth promoters. So in US or in American, Latin America, South America, and North America, they're still using a lot of AGPs, and they are authorized to be used in the feed, and followed by Asia. And you can see here that, let's say in Europe or in Middle East, in Africa, they're using less antimicrobial growth promoters authorized for feed or for growth promotion. So here we can see the relation of the antibiotics or the AGPs that we use in animals and the antibiotics that we use in human health. So for example, we are using aminoglycosides in human health, and it is classified as critically important in human therapeutics, but we're also using that in our chickens and in our pigs, like the antibiotics gentamicin and neomycin. And then also with other classifications, macrolides, beta-lactams, fluoroquinolones, they are considered critically important to human health, but then we're still using that as AGPs or antimicrobial growth promotants in production of food animals. So this is why there's a strict or stringent regulations on the use of AGPs, because those antibiotics that are being used in human health are the same antibiotics that we are using in production of food animals. And here we can see in the US that the trend is changing. The way they are using antibiotics is changing. So this is not a survey, but the data they have gathered from 2015 to 2019, the broiler production in the US. So from 13% of not using antibiotics as a growth promotant, from 2015 it's 13%. By 2019, 58% of broiler production in the US is producing broilers without antibiotics. So I guess at this time, it's more than 58%, let's say 80 to 90% of broiler production is not using antibiotics as a growth promotant in their systems. So when we consider antibiotic-free or no antibiotic ever production in broilers, there are a lot of considerations and of course challenges. So let's say if you want to produce an antibiotic-free or any broilers, you have to really follow the program on your coccidiosis control, and feeding program must be designed to succeed in an ABF system. So this means that we have to totally reduce the amount of anti-nutritional factors that would compromise the gut health, and then feed ingredient quality. The quality control is very important. Gut health, healthy gut bacteria must be maintained, flux bacteria and virus load must be reduced. So there are these considerations, and of course the challenges on production, management, health, and on animal welfare. So they have more considerations and challenges than let's say the benefit, but it takes a long time to produce chickens which are totally devoid of antibiotics, or they did not use antibiotic at all. So this is like a good survey that they have seen, like published by What Global Media, the percentage of antibiotic-free animal production that they have seen over the last year. So the response of the people are overwhelming. Like almost 50% has responded that between 50% to 100% of production will be antibiotic free. So there's a good response on how people view antibiotic free production in the next few years. So this is like a good response, especially for those who has started antibiotic free or no antibiotic ever animal feed production. So among the feed additives, this shows like which additives they had experienced maybe to be effective, ineffective, or they don't know the results yet, but which of the additives now in the market has been is seen as a good antibiotic replacement with notes on being effective or ineffective. So if we look at which are the most effective ones that can be used as antibiotic replacement, so we can see here organic acids, number 1, followed by probiotics, enzymes, prebiotics, phytogenics, and yeast. Actually, yeast and prebiotics, they could be like in the same category. So we can see that most of the products that are being developed now or being promoted or sold in the market are all of these types, those which can be effectively replacing antibiotic in the diets. And then when we look at the what are the health challenges after antibiotic reduction or elimination, so what they are expecting, there would be challenges more on necrotic enteritis and coccidiosis, because if they totally remove antibiotic into the diets, this would be the issues that will really come out in terms of broiler production. And then what are the challenges that is being faced when we are producing on an antibiotic-free world? So there's a great response on the cost of these feed additives. Like they are expecting higher feed additive cost and inconsistent results with the use of these alternative feed additives. So still there's a black box here on the efficacy of the alternative additives for antibiotics. So, what are the additives that were used as replacement to AGPs? So, a lot of response has been using probiotics. So there's like 73% of the respondents had used probiotics as alternative to AGP, followed by organic acids, enzymes, phytogenics, or the essential oils, prebiotics, and others. So if we look at this like replacement to AGPs, the responders or those stakeholders of the industry, they have used these types of additives and might have used them in the past or are still using at this time, and they found this effective. So that's why we noticed that a lot of companies or a lot of suppliers are also investing or really promoting this type of additives. So if we look back at the functionality of the gut, generally gut function as an it functions as an epithelial barrier for, of course, for the pathogenic microorganisms. It contains the microbiota. The microbiota balance depends on the conditions of the gut. It controls oxidative stress and homeostasis. It is responsible for immune response, and most of all, the gut is the main organ which will facilitate the digestion and absorption of nutrients. So dealing with these gut functions, we know how to choose or select the best alternatives for the AGPs, because we can target which of these gut functions we would like to focus on. So what are these alternative solutions to AGPs? Now I bring back the dysbiosis, the vicious cycle of dysbiosis. And as I mentioned, if we know which particular aspect of gut health we would like to focus on, we know how to use our available products in the market, the available tools or technologies, or even the alternative solutions that we have in our feed mill or in our farm. So what are these highly digestible ingredients? So there is this difference. Let's say the soybean meal that we use, the hulled soybean meal that we use in the formulations versus the processed soybean meal. Also with let's say with cereals, there is this like corn or wheat, and there are processed corn like cooked corn or extruded corn, or some would be like processed or extruded cereals. So the more digestible ingredients we use, the more the less the risk that we can give to the gut, or we can provide to the diet. So our recommendation for nutritionists, the usual recommendation for us is when we are formulating chick diets that's 0 to 10 days old, we try to use highly digestible ingredients. We try to consider the digestibility of all the materials that we are using in our feed formulations. And then for us to maximize the function of the gizzard, we have to check on the feed form or the texture. Let's say, what is the particle size? What is the ideal particle size of corn when we want to achieve functioning of the gizzard. So let's say for broilers, I would recommend like 900 to 1,100 microns of particle size for corn, so that the gizzard will function and it will lead to healthy gizzard, healthy gut. And then the use of enzymes, of course, we talked about this already, but all these enzymes in the market, proteases, carbohydrates, lipase, phytase, they are good alternatives to AGPs. Why? They improve the digestibility of the raw materials that we have. For example, with carbohydrates, we have silanase, beta-glucanase, alpha-galactosidase, mannanase. We have a lot of enzyme options to improve digestibility of this fiber or these carbohydrates that are not digestible to the animal. So in the case of proteases will improve the protein digestibility, so we will not have high levels of undigested protein in the animal's gut. So when we have low, or when we avoid high levels of undigested protein through proteases, we are avoiding the gut to be compromised. So organic acids, we have a lot of organic acids already present. So their main function, of course, is on pH reduction. Some organic acids would have bacterial or bactericidal or bacteriostatic effects. Some would have both. And of course, this is already prevalent, the butyrates and monolurins, alpha monolurins. So they are considered or classified as short chain fatty acids, the butyrates, and the medium chain fatty acids. If you have heard of the monoglycerides of fluorines or this esterified lauric acid. Emulsifiers, they are considered nutritional emulsifiers when they improve lipid digestibility, because there are also emulsifier which is considered technical emulsifier if they help in the processing, or they reduce the use of energy in processing. So emulsifier which are nutritional would improve lipid digestibility by improving the digestibility of those oil sources or lipid sources, like saturated lipid sources. Polyphenols, a lot of options as natural antioxidants. The grape extracts, you might have heard of these berries or fruit extracts. So they contain high levels of natural antioxidants. They are also looked at as natural alternatives to antibiotics, which will prevent oxidative stress. And then we also have these osmoregulators, categorized as betaine. Not much options in the market, but they also help in oxidative stress. Phytogenics or essential oils, they are plant extracts which act as immunomodulators, or they also have antibacterial effect or antimicrobial effect. Yeast cells or live yeast cells, yeast cultures, yeast carbohydrates. So the focus now is on the content of the beta-glucans and mannan contents of these yeast carbohydrates. So later I will have some discussions on that. Marine extracts or peptides, they are derived from algae, seaweed, bioactive peptides, which helps promote immunity, and they are also considered as alternative to AGPs. Just saw this in some literatures in Europe, where they use colostrum as a source of as an alternative to AGP by promoting the immunity or enhancing immunity of the chickens. And then, of course, it's actually a normal content or a normal ingredient feed additive that we use in our feed formulations. The toxin binders, they can be clay minerals, or they can contain enzymes or other natural products which will reduce the or bind the toxins, or the natural products will reduce the effect of mycotoxicosis. We have probiotics. These are considered direct-fed microbials. They function in a different fashion as antibiotic, the different fashion from antibiotics. Their mode of action is more on the competitive exclusion, and probiotics are also known to enhance digestion. So later I will have an elaboration on that. On prebiotics, these are carbohydrates which will promote fermentation in the hindgut. So prebiotics would also function as physical barrier. And then fibers, the fiber that we know before, which is an anti-nutritional factor in the feed, can be now used as an alternative to AGP. So we have to select which ones. Is it soluble, insoluble? We consider the fermentability of the fiber, because this fiber, those of the soluble fiber ones, would enhance or stimulate volatile fatty acid or the butyric acid production in the hindgut. And while insoluble fiber, they will promote peristalsis and rate of digesta passage. So we can make use of this fiber. We can make or we can maximize the fermentability of the fiber that we have in the feed to promote volatile fatty acid production or butyric acid production. So for trace minerals, some of these are the zinc, or although they're already banned on zinc, copper sulfate, or different forms of copper. They have antibacterial effects, and some would have immune response effects. Then we also notice that we have functional amino acids. They are precursors of energy and functional molecules. So they also use as signaling molecules and microbiota modulators. So they're not just used as amino acids to build proteins, but on a different level, they are used as immunoenhancers. So the example that I have given on using highly digestible soybean. So when we are using soybeans, the raw soybean, the dehulled soybean, we are still dealing with high levels of trypsin inhibitor, high levels of beta-conglycinin, and oligosaccharides, the galacto-oligosaccharides. So all those three anti-nutritional factors of soybean would impair or would provide great risk for gut health damage. And then when we process soybean, like the soy protein concentrate, or some are classified as soy protein isolate, enzymatically treated soybeans. So they have undergone this process. So after extraction, they are defatted. Ethanol extraction would bring the soy flakes, and then by heat treatment and grinding, they will come out with soy protein concentrate, which has reduced anti-nutritional factors. So in soybean processing, not just by cleaning, cracking, and dehulling, because this is the soybean that we use in our feed meals, the processed soybean would have low levels of these anti-nutritional factors, the trypsin inhibitor, galacto-oligosaccharides, and beta-conglycinin. So in most formulations, although sometimes the price is prohibitive, we have to use processed soybeans to help the chicks or the young animals, to help them digest the raw materials or the ingredients that we have in our feed formulations. So how about the enzymes? This has been discussed by previous presentation. So in general, how do we see enzymes as an alternative to AGPs? So with the function of enzymes being able to reduce the viscosity of the diet, it destructs the cell wall of the raw materials. It helps promote production of prebiotics or generation of prebiotics. So with correct enzymes or with the proper enzymes that we use in our diet, we would be able to expect all these benefits, and that would lead to healthier or a more balanced gut microbiome, then would eventually be an alternative to the use of AGPs. So generally, when enzymes improve digestibility of these fiber fractions from plants or from the feeds, we remove that anti-nutritional factor in the feed ingredients and also in the feed, and that would reduce the incidence or the challenges that we might have on our gut. So we tend to reduce the use of we tend to reduce the use of antibiotics, or we can safely remove the AGPs that we have in the diet if we are providing good balance of enzymes in the diets. So although, as you might have heard, there's no single bullet or silver bullet that would be identified as the ultimate alternative to AGP. All these available products in the market, you can select and evaluate each one of them. And as I have mentioned, the most consistent one that I have seen is the use of enzymes, or those which can help digest the anti-nutritional factors or the NSPs in the diet. So there's this like very nice article also on the link between microbiota and feed enzyme. If you have time, you can read on this. Like they the enzyme's role is not just on digesting what is undigestible in the feed or in the raw material, but it has an additional role on promoting gut health, both in swine and in poultry. So now we shift to phytogenics. We have a lot of herbal plant material sources. We generally term them as phytogenic. So these phytogenic feed additives or botanicals, they are substances of plant origin added to animal diets to improve animal performance. And most of them are in the form of essential oil. So they extract the oil of these plant materials or herbs. Some of them are spices that we use, and they have this particular bioactive ingredients. For example, the phenols and flavonoids. For example, oregano would have high levels of thymol and carbapenem, and those active ingredients or bioactive components would serve as the would have this antibacterial or antimicrobial action, and that is already used as AGP. So we can see here that the use of these phytogenics from being for being an antimicrobial to digestibility enhancer, a lot of these AGPs are, a lot of these phytogenics are being used as AGP replacement, or as one of those alternative solutions to replace AGP in the animal's diet. So phytogenics has a lot of functions, and nowadays I think a lot of these producers, of these manufacturers, are identifying which particular bioactive compound is present in this plant material that I can use as alternative to AGP. So it may vary from country to country or from origin. Some of the botanicals or plant materials that are present in tropical countries are not present in temperate countries. Some are some botanicals can be found only in this region of the world, but cannot be found in other regions of the world. So we have a lot of options for these phytogenics, and unfortunately, most of the researches, they saw inconsistent results. Of course, with so many options, they have seen inconsistent results with the use of these phytogenics as replacement for AGP. Okay, so how about organic acid? So how does organic acid, let's say formic acid, would work as an alternative to AGP? So as antibacterial, these organic acids, when they are non-dissociated, that means the hydrogen ion is still still intact with the carboxyl group. They can cross the membrane in this form, and then when they dissociate, they will reduce the intracellular pH, and when the presence of hydrogen ion is there, it will exhaust the energy of the bacteria and damage the DNA, and that would cause bacterial death. So in the cases of organic acids, I think the most used one is formic acid, and it is also one of those alternative solutions to AGPs. And also in the dissociated form, this organic acid reduces the extracellular pH. So when you have low pH, it also damages the microbial cell membrane. So it would help kill the bacteria. And among the organic acids that we are using, I think we always include formic acid in those concoctions of organic acid mixture, or as acidulant or acidifier. So butyric acid production. Although there are products already which are ready butyric acid, or the butyric acid preparation, some of them are coated, some of them are still in pre-form. Butyric acid has been known to reduce inflammation. It improves epithelial integrity. It alters microbiota composition, and it modifies the metabolism of microbiota. But when we have fermentation of fiber, we can also help facilitate production of butyric acid. So butyric acid has like this for mode of action or function of butyric acid has been proven in laboratories, also in trials, in farms, in practical conditions. But you might have heard recently that we can use the fiber in the diet, or fiber supplemented into the diet to produce butyric acid. This is like using soluble carbohydrates or soluble fiber. When they are converted into monosaccharides or oligosaccharides, Then they enhances production of short chain fatty acids, lactate, and then this lactate can be converted to butyric acid. And the cross-feeding is like when you have butyric acid, it also helps stimulate production of other short chain fatty acid. So butyric acid is one of those organic acids that is very promising as an alternative to growth promotants or antimicrobial growth promoters. And we can supplement them into the diet or help promote them through supplementation or maximization of fermentability of fiber. So how about probiotics? Probiotics, they are DFMs or direct fed microbials. So we have a lot of strains of probiotics, a lot more of strains coming in the future. They are most extensively studied solution to gut health. And if you remember the graph that I have shown before, probiotics is the widely used alternative to AGPs. They could be effective as is, like a single strain or in combination with other product solutions. They could be applicable as early as, let's say, in the day 1 or in the starter stage, and all throughout the animal's stage of growth. And the 3 modes of action of probiotics, they can be generally classified as first is mode of action on the feeds. It enhances nutrient absorption. So when we use probiotics, the tendency is we provide the microbiome with a good balance that the beneficial microorganisms grow and replicate and overgrow the pathogenic microorganisms. So when that happens, you are providing beneficial microorganisms that would help promote production of enzymes and promote functionality of the supplemented enzymes into the diet. So that's how it enhances nutrient absorption. And then probiotics are, of course, known to directly antagonize those pathogenic microorganisms. So they balance the population that they would like to maintain good gut health. That is our goal, to maintain good gut health by providing more beneficial microorganisms, bifidobacterium, and over those pathogenic microorganisms. So on the host, probiotics, the mode of action is more on competitive exclusion. So if you have, of course, if you have more beneficial microorganisms, that would reduce the level of pathogenic microorganisms. So on the nutrition side, how probiotics would particularly influence the nutritional status of the animals. So it increases the digestive and absorptive capacity of the gut. That means when we provide probiotics, we have more beneficial microorganisms, then more enzymes are produced. The enzyme that we added would be used more efficiently, and that would lead to assimilation of nutrients. So more nutrients will be used. That would lead to better performance. And then, of course, probiotics are known to facilitate conversion of carbohydrates to acids. That means you have lower pH, so lower, the more acidic, the better for the proliferation or reduction of pathogenic microorganisms. And then It ensures the feeds are metabolized, nutrients are absorbed and utilized for specific functions. So when we say it increases the digestive and absorptive capacity, we have been talking about more enzymes are available. So probiotics have been known to stimulate more endogenous production of enzymes. So the more nutrients will be digested and absorbed. And probiotics, when it performs its task, it could allow reduction of proteins or amino acids and energy in the diet. That means you can have more savings on the feed, or you can reduce the feed cost with the use of antibiotics, because you are expecting that more nutrients will be assimilated, the better the efficiency you will have, and then you can reduce the specifications of amino acids or energy in the diet, and that would eventually reduce the cost of feed. Okay, so for prebiotics, these are considered yeast bioactives. So in the yeast cell, you will see that you have the cell wall, you have the cell membrane, you have the composition of the yeast cell. So prebiotics, one of which is like it's enzymatically hydrolyzed yeast carbohydrate. That means we can make use of the cell wall and the contents of even the cell membrane of the yeast as prebiotics. So what is present in the cell wall are mainly the mannans and beta-glucans. So they function as prebiotic when they serve as food for the microbes in the gut, because prebiotics are the preferred food or the preferred fuel of this microflora, of these beneficial microorganisms. So when we have food in the microflora, so we will promote growth of these beneficial bacteria. So for example, the mannan oligosaccharides, which is present in the cell wall of these yeast bioactives, they can bind pathogens, like directly binding the pathogens, while the beta-glucan components, they improve immunity by enhancing macrophage activation. So these components of the yeast cell wall, or categorized as prebiotics, they can be both directly acting on the pathogenic microorganisms, and at the same time, they can improve immunity of the animals. So one of the unique properties of this prebiotic type is it is hydrolyzed, which increases water solubility and improves bioavailability of this product. So prebiotics are basically containing beta-glucans and mannans. So they are the soluble portion of the carbohydrates. They can be fermented by the microbes to produce short-chain fatty acids. So what prebiotics do is that they help stimulate production of this butyric acid in the hindgut. So if you look at the previous figure that I have shown, butyric acid, aside from being supplemented as butyric acid itself, you can help promote production of butyric acid by supplying fiber or carbohydrates. So fermentation of these carbohydrates would help produce butyric acid. So prebiotics are known to be beneficial, to help proliferation of beneficial microorganisms in the gut. So when beneficial microorganisms proliferate, tendency is the pathogenic microorganisms to to reduce the population of pathogenic microorganisms. And it enhances also the endogenous enzyme production, which will lead to improved digestion. It enhances functionality of the villi, because when you have high levels of butyric acid, that is also good for the villi, as it is the butyric acid served as the energy source or the food for the intestinal lining. And then, of course, with highly functional gut, we improve the absorption of nutrients. And overall health improvement is expected, which also reducing the risk for diseases or resistant. We will have high resistance to diseases, and we will have better immunity when we improve the overall health status of the animals. So, relating the gut functions versus the gut health solutions that we have. As I've mentioned before, when we have these issues on gut health, let's say if we have to repair it, we have to maintain the integrity. If we want to push through more butyric acid production, if we want to enhance immunity or develop more beneficial microorganisms, promote fermentation, or just to provide intestinal barrier, we have a lot of options. And those options, those product options are available. We just need to carefully evaluate each one of them. So this short chain or medium chain fatty acids, prebiotics. Now we have postbiotics, as they say, but it's just the terms or the use of terms. Enzymes, fibers, yeast, carbohydrates, phytogenics, beta minerals. So we have a lot of options, and it's up to us. It's up to our production systems on how we evaluate and how effective we see them. So a product that may be effective in my farm may not be effective in your farm, or an alternative to AGP that I have proven to be effective in this farm might not be effective in another country or another region or another farm within the same region. So it depends on how we evaluate them and how we use each of these alternative solutions. So summarize, there's an increasing demand, of course, for feed and food production, and that prompts us to produce animal products in the most efficient way possible. And we have always been dependent on AGPs. Now is the time that we have to be more reliant on what are the alternatives to these AGPs. So reduction in the use of AGPs will become a way of life for both human and animals. So it's not just in animal production that they want to remove or to cut off on antibiotics. The functionality of the gut is as important as keeping the animal host alive, and that means we're heavily relying on antibiotics, and then we have to find solutions, because there will come a time that that we might be very limited with options on using, or there are a lot of regulations already on using antibiotics, and functionality of the gut is our key goal in animal production systems. So ADF or NA production will set a new paradigm in animal production business, but as you have seen, there are more challenges, there are more considerations in this type of animal production system. No antibiotic, especially the no antibiotic ever. And I guess it's only in like in Western countries where they have already employed ABF or NAA production. Although there are producers in Asia which has started on that, particularly one here in the Philippines. They started with NAA production, but they have more problems than than solutions. Okay, so we can make use of the available tools and products in the market to maintain gut health and nutrition. And each product has a fair chance of being a part of that alternative solution to replace AGPs. And with that, I thank everyone. I guess that's the end.
Thank you very much. There are a couple of questions in chat box. Can you please address them?
Okay. Your view on quenching, this is maybe quorum quenching products for gut health. As I've said, I'm not a veterinarian, but I'm happy to discuss what I have learned from probiotic discussions. So this is more on like the use of certain compounds, or let's say those which are we can get from probiotics. The quorum quenching or quorum sensing, I'm not particularly referring to that term, but I think with the use of probiotics, they would be able to what I remember is that they would be able to send signals, those microorganisms. If you proliferate them, they would send signals to the microbiota not to produce this type of organism, something like that, like to reduce the level of pathogenic microorganisms. That is what I understood with this quorum quenching or quorum sensing. But you can refer to a veterinarian with that. I'm not sure if that's what you're looking for, Ms. Stephenson. Sorry, Mr. Stephenson. Okay. From Bharat, is there any effective phytogenic botanical extract to use for coccidiosis? You know, Dr. Vivek has mentioned to you that I am working for VetWorks. We do a lot of studies, trials, practical experiences on coccidiosis. At this time, our founder still is not recommending or maybe hasn't found any phytogenic or plant-derived alternative to the chemicals, ionophores, vaccines for coccidiosis control. So there's a lot of options. There are a lot of options. As I've mentioned, the one that I see, which is very promising, is the Quillaja saponaria, the saponin, yeah. Quillaja saponaria. That's what I see the most promising based on the studies that I have read, and a lot of studies already on that aspect. But we are not like recommending any phytogenic botanicals yet for coccidiosis control. We still have to deal with vaccines, and then the anticoccidials, the ionophores, and the chemicals. Thus, the risk of difficulty in detection of bacteria like Salmonella in E. coli exists by the application of organic acid and lowering the pH in feeds. Risk of difficulty. I don't get the question. Like, there's a risk in difficulty of detection. Okay, when we apply organic acids and when we lower the pH, we reduce or we kill the bacteria, or when let's say particularly formic acid, when we use formic acid in our feed production, we are killing salmonella, and I'm not sure if we are also killing E. coli, but on feed security, we try to use strong organic acids like salmonella, formic acid, or formaldehyde to reduce the amount of salmonella in the feed. I am not sure if E. coli is also covered by organic acids or high levels of organic acids and or formaldehyde. But with salmonella, we did a lot of studies here that formic acid or formaldehyde would lower salmonella content in the feed. Thank you, Onkar. Dr. Praveen, please consider a case that best quality NDP, protease, phytase, and probiotics are being used. Please arrange following in terms of value for money in performance, FCR, weight, livability, gut health. List is butyric acid, benzoic, yeast, MOS, phytogenics on top, alpha galactosidase on top, cocktail enzyme. Okay, so Dr. Praveen, what you are requesting is to arrange in terms of value for money in performance. Okay, if I have these options, if I have this list, based on my personal experience, I am consulting to farms, broiler farms, layer farms, broiler breeders, pig farms. I am formulating diets. I'm an animal nutritionist formulating diets for the last 25 years. I also have my own farm. I have a layer farm. So what I have seen that is most beneficial and most economic in my formulations, value for money first in my list would be enzymes, of course, but you said here it's on top, galactosidase and cocktail of enzymes. So it would be followed by butyric acid and then yeast MOS. Yeast MOS, I have very good results in my own farm with the use of yeast MOS. Actually, yeast MOS plus beta glucans. So that will be top 2. Butyric acid number 1, yeast MOS plus beta glucans top 2, and then benzoic top 3, phytogenics on the last. Sorry, I have not seen like consistent results with phytogenics. That's the reason why. Okay. Onkar, giving signal to bad pathogens to babe. In short, yes, that is the quorum sensing, right, Onkar? Dr. Yeah, Mr. Onkar. That's what I remember about quorum sensing or quorum quenching. Okay. Okay, thank
Okay,
you. Thank you for
thank
the
you.
help.
Thank you very much, Dr. Miriam, for your wonderful talk. I'm sure people have developed a greater insight to the alternatives of AGP in poultry after this talk. And thank you very much for your generosity, for your valuable time. Back-to-back 2 presentations with question and answer session, a total of 3 hours with us. It means a lot to us.
Thank you also. And if you have like questions or some inquiries, nutrition related, not veterinary related, I would be happy to answer them or to help you with that. You have my contact details, and yeah, very much happy to help you.
And we look forward to cooperating with you in future as well, to disseminate your expertise, knowledge for the benefit of global livestock, poultry, and feed industry. Thank you very much.
Thank you. Thank you for this opportunity, and have a
Thank you.
good afternoon to everyone.
Thank you.
Thank
So we
you.
already, thank you.